Welcome to the XFO Intelligence Podcast. We often imagine the future of artificial intelligence inside, these gleaming data centers. Yeah, powered by just immense grids of electricity. But today, I want to take you somewhere different. Picture a laboratory in Japan, and in that lab, a petri dish containing a single brilliant yellow cell, a slime mold. It has no brain, no neurons, no nervous system. Yet, when you place it in a complex maze with food at two ends, it does something miraculous. It extends its body, it explores every path, it retracts from dead ends, and then within hours, it forms a single perfect tube. This tube represents the most efficient possible route between the food sources. It solves a complex optimization problem using almost no energy. Now, contrast that with our current AI. Training a single large language model like GPT-4 consumes enough energy to power nearly 1,000 American homes for a day. Right, and at a cost estimated north of $60 million. This isn't just an environmental concern. No, it's a fundamental limit on progress. If we keep going on this path of just scaling up existing architectures, we're going to hit a physical and economic wall, and long before we achieve anything resembling human-level general intelligence. The contrast between the slime mold and the supercomputer couldn't be more stark, or really more illuminating. At XFO Intelligence, our research into what we call the deep augmented thinking method was inspired by this exact paradox. So we started asking, what if we've been chasing the wrong metric? What if intelligence isn't about raw power? What if it's about efficiency? This led to a really surprising convergence of ideas from biology and neuroscience. For decades, AI researchers looked to the human brain as their model, but they may have been focusing on the wrong level of analysis. There's a recent revolution underway in consciousness studies, a landmark adversarial collaboration. That's where scientists from competing theories team up to test their ideas against each other, produced a startling result. The old idea of consciousness as some top-down function, a sort of CEO in the prefrontal cortex, that didn't fully hold up. Instead, the evidence points towards something more subtle. Yeah, consciousness as an emergent property of optimized information integration, happening mostly in the brain's posterior regions. It's not about centralized command, it's about hyper-efficient distributed coordination. And this is where it all connects back to our humble slime mold. Both systems, the conscious brain and the foraging slime mold, they achieve sophisticated outcomes through distributed coordination. Both prioritize energy efficiency above all else, and both use simple components following basic rules to produce complex, intelligent behavior. Right? This suggests that consciousness, far from some mysterious ghost in the machine, might actually be nature's ultimate efficiency hack. One of the most powerful concepts to emerge from this is the ignition principle. Imagine most of your brain's work as quiet, local conversations happening in different neighborhoods. Very efficient. But when you encounter something truly new or challenging, that localized activity can suddenly cross a threshold and ignite. It becomes a global broadcast available to the entire system. This allows for this dynamic balance between exploration, searching for new solutions, and exploitation, using the known efficient ones. And current AI just lacks this graceful dynamism. It's either rigidly specialized or, chaotically general. So what would an AI built on these principles, the blueprint for deep augmented thinking, actually look like? Well, first, metabolically constrained networks. Imagine an AI with an energy budget. It would be forced to make trade-offs, deciding what's truly worth processing deeply, just like our brains do. Second, dynamic ignition mechanisms. The AI would have built-in thresholds to escalate processing from local to global only when it's necessary. So routine tasks would stay cheap and efficient, while novel problems would trigger this widespread integration. And finally, a natural exploration-exploitation balance. Inspired by the slime mold, the AI would automatically balance trying new approaches with relying on proven methods. This changes the entire game. It suggests that we've been measuring AI progress all wrong. We've been obsessed with scale, more parameters, more data. But consciousness research and the slime mold tell us that integration quality matters more than quantity. A brain with fewer neurons but superior integration can outperform one with more neurons but poor connectivity. This is why just making AI models bigger is hitting a wall of diminishing returns. It's not about being bigger, it's about being smarter with the resources you have. For the AI researchers and developers listening, the call to action is to design systems that optimize for information integration per unit of computational cost. For the cognitive scientists, this deepens the view of intelligence itself as an optimization problem under constraints. And for the family offices and investors tuning in, this points to a crucial strategic insight. The next trillion-dollar opportunity in AI may not come from the company that builds the biggest model. It's going to come from the one that solves the energy and efficiency crisis. We're not trying to replicate subjective experience. No, we're reverse engineering nature's most profound efficiency secrets to solve our most pressing engineering problems. What emerges is a unified theory of intelligence. From the slime mold to the human mind, intelligence is the art of doing more with less. And in a world of finite resources, that may be the most important problem any system can ever solve. Now, here's a question we'd like you to think about. If we built an AI that's forced to operate under energy constraints, making trade-offs about what to learn and what to ignore, will it develop something that looks like its own form of priorities or even values?